So in pre-calculus and college algebra, I teach my students, do not ever write that x plus 1 over x plus 1 is 1. That's not true. Only if x is not negative 1. 5 over 5 is 1 no matter what. But x over x is not 1. Only if what?
X is not 0.
That's it. This is the correct answer. 1 if x is not 0. 1 if x is not negative 1. 1 if x is not negative 2. Okay, do I owe you anything else? Are all steps clear here?
Yes.
Anyone else? Other questions for me? Is there anything else I owe you other than morally? I owe you morally. But is there anything else? Okay then. In that case, I'm on page 5, and I'd like to continue with another example from 2.4 again. The formal, also called precise definition, or epsilon delta definition, or formal definition of the limit. Okay, I hope you come back with other questions from WebAssign about this on Tuesday. But let's look at another example. Something like limit as x approaches 10 from 3 minus 4/5 x. 1 second. Yes, Beth?
I submitted.
Thank you. Give me 1 second.
I'm sorry.
My apologies to all of you. She's the last one. Okay. I'm checking Beth, 1 second.
Do you want me to take pictures and scan them in now?
I thought you did that. Okay, so you submitted it in Canvas and you are just uploading now.
I have to take the
Yes,
pictures.
thank you so much. I'll wait. My apologies. Okay. So -5. Okay. So we are asked to use epsilon delta definition to prove this. So we will have to write the equivalency, double equivalency symbol. Good. And we continue. For every epsilon positive, I will always find, there exists a delta positive such that 0 less than, I need x minus a less than delta. Can anyone give us x minus a here for our example? Oh, I forgot to say, when x is 10, we have to check, right? We don't. I mean, this is not a tricky question. So 10 divided by 5 is 2. 2 times 4 is 8. 3 minus 8 is -5. So everything is correct. So here I need to put x minus a. What will I write? What is x minus a for us?
X minus 10.
Very good. Awesome. This will always imply less than epsilon. And in here we have to have f of x minus L.
3 minus
I'm sorry,
4.
it's submitted.
I see it, Beth. I have 4 pages. Is that correct?
Yeah, that's right.
Thank you. See you next week. Bye. Very good. My apologies. What did you say? Forgive me.
3 minus 4/5 x plus 5.
Very good. Awesome. Minus the limit, which is plus 5. Awesome. Excellent. We always start here. That's our first step. So we have to combine like terms. So this is the absolute value of 8 minus 4/5 x less than epsilon. What is our next step? Of course, we have to find the least common denominator, right? So what would be the least common denominator?
5.
Very good. Remember, this is over 1, which means it has to take a 5 at the top. We have to multiply 8 by 5. So this will be 40 minus 4x. The next step, we have to factor the numerator. Remember what we are after. And this is not cheating. This is what I'm after. From all this, I have to get on the left-hand side the absolute value of x minus 10, the less than equals less than symbol, and blah, blah, blah with epsilon. And that will be delta. So how do I...
What's written before the delta in the middle, the one that has like a bit of the middle of the page?
This one?
Yes, right there, right before the delta.
I recycled it already. So it's this symbol. There exists. So we have for every, there exists, and such that, for any, or every, or all, this, there exists, such that. Oops, look. Okay, I put it twice. My favorite prop. Okay. So then how do I proceed here?
Do you factor it?
Yes. What will I factor out at the top? You cannot factor out of the absolute value. I know you didn't say that, but I'm emphasizing and re-emphasizing. We cannot factor out anything from the absolute value. So what will I factor out inside here?
I believe a 4.
But negative.
Oh, yes, you're right.
Excellent. So then what do we have left? Exactly what I'm after. It better be.
Yep, 10 minus x.
You mean x minus 10.
Sorry.
Very good. So now I have to write the next step. Although you can say it's obvious, maybe, but I have to write it. I have to write next the absolute value of negative 4, the absolute value of x minus 10, over the absolute value of 5. I have to show these steps. You cannot take anything out of the absolute value. You have to show that you are using the properties of the absolute value. The product is the product of the absolute values. The ratio is the ratio of absolute values. Now you can replace this by 4 and of course this by 5, and you'll tell me what to do as the last step. All I want is the absolute value of x minus 10. I don't want anything else. This is what I'm after. So,
Well, we can multiply by 5, right?
over
5 over 5. 5 over 4?
That's it. So 5 epsilon over 4. When I multiply here by 5 over 4, these go away. I have to multiply here by 5 over 4. Is this okay? Any
At the
questions?
beginning, where did we get the absolute value from?
What do you mean? I mean, I'm not sure which absolute value are we talking about. Everything is in absolute value. This is a distance.
So
This is a distance. It has to be absolute value. This is a distance. It has to be absolute value. We start here with the absolute value. We continue with the absolute value. We continue with the absolute value. We break it up based on the properties of the absolute value. I cannot touch this. This I cannot touch. This is completely carved in stone. I replace -4 by 4. -4 in absolute value by 4. Absolute value of 5 is 5. And I'm solving for the absolute value of x minus 10.
That's not what I meant.
Oh, of course. Sorry about that.
What I meant was at the very top where it's like the absolute value of x minus 10. Is that the question that they're asking? Asking us to show how that's possible? Like, where is the first instance of us using that for this specific problem, I guess is what I'm trying to say.
So you understand I started here.
Yeah, but it doesn't look like there's absolute value at the beginning of the problem. I'm trying to figure out where it develops.
You mean here?
Yeah.
But that's the formal definition. I have to write the formal definition. This is carved in stone. I can't change that. So this equals this implies this, and this is the definition. This is the epsilon delta definition. This is carved in stone. That has to be memorized.
I have a question I think might overlap with his.
Yes?
This part right here at the end of the formal definition, you have boxed in the green square. Could you read that to me? Because I understand you're saying every delta over 0 has every epsilon over 0 has a delta over 0.
You mean greater than 0, not over 0, right?
Yeah, greater.
Okay,
yeah, greater.
yes.
Then that blocks. Could you read that out to me? That's the only part I'm having trouble with.
This?
The box. So this absolute value over delta, that's the distance you're talking about?
Okay. Let me dig up my previous lecture. Okay. So the formal definition of the limit says this. If I choose an epsilon positive, in other words, 10 plus a little bit, 10 minus a little bit, a symmetric interval, I will always be able to find a delta around a positive delta, such that this distance, every time I pick an x here, so that this distance, the absolute value of x minus a, less than delta, the distance between x and a is expressed as the absolute value of x minus a. This distance is the absolute value, that's the only way to present a distance. Between x and a is the absolute value, smaller than delta, not bigger than delta, smaller than delta, such that f of x will fall close to L, but the closeness is determined or presented as a distance, the distance between f of x and L. Why is this guaranteed? Because the limit exists. For every epsilon, I will find a delta such that when I pick x close to A, f of x will be close to L. So for every epsilon, I will find a corresponding delta next to A, right? Close to delta. I will find delta positive, such that the distance, I pick an x close to 10, so that the distance between x and 10 is less than delta. This process will guarantee that the function value for this x and the distance between the function value and the limit, which is -5, which has to be presented as an absolute value, that's the distance, is less than epsilon. So I start here. I manipulate with all algebra that I can think of. I get this, and this is what I'm after in order to identify delta. And delta depends on epsilon. So maybe you want to watch this explanation again. Maybe this is better now after we talked about it again. Is this better or not?
I think so. So
Oh, yes?
absolute value originates from x minus a.
Yes. So
That's
the
why
distance, so this one, for our case, a is 10. So the distance between the x I pick and 10, if it's at any point in time, if it's smaller than delta, the function value for x I pick will be close to -5, to the limit. How close? The distance between those two will be less than epsilon, guaranteed to fall in that interval.
Okay.
As I said, it's a little abstract, so that's why in several of my videos, I repeated it and I repeated it. Is that better?
I think I'm good.
Now, I'm not sure I answered Lewis's question. Oh, no, who else asked? Charles or somebody. Did I answer the first question? There was a question about, or it was just you, Lewis. Was it?
I was piggybacking off of someone. I don't know who it was.
Okay, so somebody, the other person, is the other person okay with this explanation, or do I need to go back?